We're going to continue our study of higher powers. We're still working with quotients. In our first problem, we have the cube root of 24x to the 7th over y cubed. Now, unfortunately, the radicand, the number inside, doesn't simplify at all. So this is a case where what will be helpful is breaking this up into numerator and denominator. We've got the cube root of 24x to the 7th over the cube root of y cubed. I'll work to the right here. Well, 24 is the same thing as 8 times 3, and I'm choosing 8 because it's a perfect cube. The cube root of y cubed is just y, so the denominator is already simplified. The cube root of 8 is 2, and the 3 will stay inside because that's not a perfect cube. By the Orndorff rule, 3 goes into 7 twice, so it'll be x squared on the outside with 1 left over, so x on the inside. That whole thing is over y. Nothing simplifies, so that's as far as we can go. I'm going to work to the right on the second problem. Didn't set this one up real well. We have the 4th root of 48x to the 10th over y to the 8th. Nothing simplifies, so we're going to break it up in the numerator. The 4th root of, I'm going to skip a step here, or not really skip a step, but I know that 48 is 16 times 3, and 16 is a perfect fourth. X to the 10th. My denominator is the 4th root of y to the 8th. Continuing to work to the right, we've already said that the 4th root of 16 is 2, so that's why the 2 will come out. That will also leave us with the 4th root of 3. By the Orndorff rule, 4 goes into 10 twice, so that'll be x squared on the outside with 2 left over, so x squared on the inside. And my denominator, the 4th root of y to the 8th, is just y squared. There's our final answer there in the corner. Go ahead and hit pause and try these two problems. Let's see how you did. This doesn't simplify, so we'll break it up into the numerator. The cube root of 168 c to the 10th. But I'm going to save some time here. I'm dealing with perfect cubes. So 8 is a perfect cube. So this is the same thing as 8 times 21 c to the 10th. My denominator stays the cube root of d to the 9th. But we can simplify this now. The cube root of 8 is 2, so that's why that comes out. Cube root of 21 doesn't break down any further. 3 goes into 10 3 times, so that'll be c cubed on the outside with 1 left over, c to the first on the inside. And my numerator would just be d to the 3rd. Last problem, we've got to break it up. We're dealing with perfect fourths. So this would be the 4th root. 80 is the same thing as 16 times 5, and 16 is a perfect fourth. X to the 10th over the 4th root of y to the 5th. Well, the 4th root of 16 is 2, and then I'll leave the 5 inside the 4th root. 4 goes into 10 twice, so x squared on the outside with 2 left over, so x squared on the inside, all over. That'll be y times the 4th root of y. Now technically we need to rationalize this denominator, but I don't want to get ahead of ourselves right here. So we're just going to stop right here for now, but it is true that that denominator does need to be rationalized to some degree or another.